All right, let's talk about a problem I'm pretty sure many of you have faced. You've got this Kafka consumer, and it just feels like it's drowning in a sea of messages. Well, you're not alone. In this explainer, we're going to go on a little journey, taking us from a super frustrating bottleneck to a high-performance, totally production-ready solution for scaling your Kafka consumers right inside Spring Boot. So, picture this. Your new event-driven service is live, messages are flowing, and then you see it. The lag starts to creep up. Your Kafka consumer is falling behind, and that backlog is just getting bigger and bigger. It's a classic scaling problem, for sure, but what's really going on under the hood?
And this graph, this is what that pain looks like. A big, scary, growing consumer lag. All it means is that your application simply cannot process messages as fast as they're coming in. So the big question is, why? Let's break it down.
Well, the problem, more often than not, starts with the most basic default setup. You have a single service, a single Kafka topic, and a single listener. It's beautifully simple, sure, but it's also a perfect recipe for a major bottleneck. Let's see exactly why that is. Here's the culprit, right here. By default, Spring for Kafka just gives you a single consumer thread. What that means is, it doesn't matter how powerful your server is, how many cores you have, messages are being processed one by one by one. This sequential processing is the bottleneck we absolutely have to break.
So how do we escape this single-threaded prison? Well, the secret is to tap into Kafka's built-in parallelism. And that journey always starts with understanding one of Kafka's most fundamental concepts, partitions.
You can think of a Kafka topic like a highway. By default, it's just a single-lane road. Kind of slow, right? But what we can do is split it into multiple partitions, essentially turning it into a multi-lane superhighway. Each one of those lanes, each partition, can be handled by a totally separate thread, which lets us process things in parallel and get way higher throughput. Okay, so now that we've got our multi-lane highway, we have two main strategies to actually start using all that new capacity. We can either scale out, which means running more copies of our entire application, or we can scale up, which is all about making a single application instance way more powerful by giving it more threads. Let's check out both.
First up, let's talk about scaling out. So, imagine we bump our topic's partition count up to, say, 10. Then, we launch a second instance of our Spring Boot app. The magic of Kafka's consumer groups kicks in, and it automatically rebalances the load. Now, each app instance is handling 5 partitions, which effectively doubles our processing power.
And the result is a clean 2 times increase in our processing capacity. The real beauty of this, though, is how scalable and resilient it is. We can just keep adding more instances, all the way up to the number of partitions to handle more and more traffic. Plus, if one instance goes down, Kafka just reassigns its partitions to the others. That's horizontal scaling, and it's a super powerful way to build really robust systems.
But what if you don't want to spin up whole new application instances? What if you just want to get more juice out of the one you already have? That's where scaling up comes in. And with Spring for Kafka, it is ridiculously easy. All you have to do is add one property to your @KafkaListener annotation. Concurrency equals 10.
And with just that one line of code, bam! Spring for Kafka spins up 10 consumer threads right inside your single application. Kafka then assigns each of those threads to a different partition, and suddenly you've got massive parallel processing and a huge performance boost. It's a really simple but incredibly powerful way to make your apps so much more efficient.
Okay, so we've scaled out with more apps, we've scaled up with more threads, we're feeling pretty good, right? But what happens when your processing logic itself is the real bottleneck? Even with 10 threads, if a single task takes a long time, it can still block its partition. To get to maximum, ultimate throughput, we have to take our threading strategy to the next level.
Now, this more advanced approach brings up some really important questions, ones we see a lot from the community. What happens to acknowledgements if the app crashes mid-process? Are you going to lose data? And what about that strict message ordering that Kafka is famous for? These are absolutely critical trade-offs you have to think about before diving in.
The core idea here is to completely separate the work. Think of your Kafka listener thread as a super efficient mail sorter at the post office. Its only job is to grab incoming messages as fast as possible and immediately hand them off to a huge team of workers. That's our separate thread pool to do the actual processing. This keeps the mail sorter, our listener, totally free to just keep grabbing new mail, preventing any backlogs from ever forming.
And this brings us right to the single most important trade-off you have to make. The standard concurrency model guarantees that messages within a single partition are processed in the exact order they arrived. But the second you start handing those messages off to a separate worker pool, that guarantee is gone. You gain incredible speed, but you lose that strict ordering. Now, for a lot of use cases, that's a perfectly fine trade to make.
So what does this actually look like? Well, we could have a small number of listener threads, maybe 3, whose only job is to fetch messages from Kafka. As each message comes in, it's immediately passed off to a much larger worker pool, let's say 30 threads, for the heavy lifting. This whole setup guarantees that even a really slow task in the worker pool will never, ever block the listeners from grabbing new messages.
We've been so focused on speed, but what about resilience? In any real production environment, you have to be ready for things to go wrong. What happens when a message is badly formatted or a service you depend on is down? You can't let one single bad message bring your entire system to a grinding halt.
And this is exactly where the dead letter topic, or DLT, comes into play. It's a really simple but incredibly powerful pattern for dealing with failed messages. Instead of getting stuck trying to process a message that's just never going to work, we just move it to a separate DLT. We can look at it later, figure out what went wrong, but the key is that our main consumer keeps running smoothly and no messages are ever truly lost.
Naturally, Spring Kafka gives us really fine-grained control over all this. The default setting is to just keep retrying a message that ends up in the DLT forever. But you can also set it up to fail immediately, or you can even turn off the DLT completely if you want. Choosing the right strategy here really just depends on what your application needs for fault tolerance.
Okay, so we've been deep in the weeds talking about concurrency and failures and DLTs, but why is this all so important? Let's take a step back and look at the bigger picture of where our little consumer fits into a modern system architecture.
We've actually come a really long way. We started with a simple, single-threaded bottleneck, and we transformed it into a fully parallel, resilient system. We figured out how to scale out, how to scale up, and how to handle failures like a pro. What we're left with is a production-ready consumer that can handle pretty much anything we throw at it.
You know, in a modern microservices world, your consumer is the engine that drives your business logic. It's the component that's responsible for reacting to events and keeping all the data flowing between services. A slow or unreliable consumer, well, that's like a massive traffic jam on the information highway. It can bring your entire system to a standstill.
So what are the big takeaways here? First, remember that partitions are the absolute key to unlocking parallelism in Kafka. Second, Spring Boot makes it so easy to scale up with that simple concurrency setting. Third, if you need the absolute maximum throughput, a custom thread pool is your best friend. Just remember that ordering trade-off. And finally, always have a dead letter topic strategy to handle failures gracefully.
So there you have it. You now have the tools and the knowledge to build a truly high-performance, super resilient Kafka consumer. You've basically turned a potential bottleneck into a powerful engine for your event-driven applications. So the only question left is, with this newfound power, what are you going to build? The possibilities are endless.